Hello. So I'm going to show you in this video how to solve for points of intersection. So we did this yesterday, which is today for me, but this yesterday was graphing, but today you have to do this algebraically. So it says, the point where two functions cross on a graph is called a point of intersection. Because functions intersect in a point, we state the solution as an ordered pair with both an x value and a y value. And then this is the video that you're watching to complete these notes. So for each pair of polynomials, algebraically solve for the points of intersection of their graphs. So the first example, we have a of x, which is x squared minus 7, and b of x, which is just equal to 2. So basically what's going to happen is that if we were to graph those two, we would get a parabola for a of x, and then a horizontal line at y equals 2 for b of x. And so you can see we're going to be able to find 2 points of intersection. So one thing I know already about this point of intersection is that there's going to be an x value, and then y will equal 2. And same thing here, an x value and y will equal 2. And the reason I know that is because this function is just equal to 2. So it's a horizontal line at y equals 2. So I'm just going to set them equal to each other. X squared minus 7 is equal to 2. And then if I subtract and make the right side equal to 0, then we can factor what's on the left. So negative 7 minus 2 is negative 9. So x squared minus 9 is equal to 0. So for x squared minus 9 equals 0, we're looking for two numbers that multiply to negative 9 and add to 0, since there isn't a term here in the middle. And so it has to multiply to negative 9, add to 0, and 3 and negative 3 will do that. So this left side of the equation factors x plus 3 times x minus 3 is equal to 0. And since we're multiplying and getting an answer of 0, then our solutions for x are the value that makes each factor equal to 0. So negative 3 for this, positive 3 for this. So for x plus 3, we get a solution of x equals negative 3. And for x minus 3, we get a solution of x equals 3. Okay? So that means the 2 points of intersection are negative 3, 2, and 3, 2. So normally we'd write that like this. Negative 3, 2, and 3, 2. All right? Okay. So each example is going to be just a little bit more complex. So we had our second function was just a horizontal line. And then the next function, or set of functions, we have a quadratic here, and then x minus 4. So this is a line that has a tilt to it. But I'm going to do the same process. I'm going to set up to make the two functions equal to each other. Okay? So x squared plus 3x minus 28 is equal to x minus 4. Because this is a quadratic, we want to make one side of the equation equal to 0, and then we can factor to solve. So I'm going to subtract the x, and that's going to go right under the 3x, and then add the 4, the constant, and that will go right here. So matching up the like terms. And then when you total this, we have a 0 on the right side. I'm just going to go backwards. Negative 28 plus 4 is negative 24. 3x minus x is positive 2x. And then x squared just comes down. So again, because this is x squared, I'm going to try and factor. I'm going to break the x's, right? One into each factor. And then I'm going to use my constant and the coefficient of the middle term. So what two numbers multiply to negative 24 and add to 2? I know I'm going to use 6 and 4 because they're 2 apart, and one of them has to be negative. And this time it's going to be a negative on the 4 because 6 plus negative 4 is equal to positive 2. So my factor pairs are x plus 6 times x minus 4. And now I can state the solutions. So from the factor x plus 6, we get a solution of x equals negative 6. And from the factor of x minus 4, we get a solution of x equals positive 4. Okay? But again, because we're solving for points of intersection, we actually have to plug these in to either c of x or d of x and find the corresponding y value because a point has an x value and a y value. I'm going to choose to use d of x because it's a little bit of a simpler equation than c of x, which has a little more to it. So for the first point, if x equals negative 6, so for x equals negative 6, then y equals negative 6 minus 4, which is negative 10. So the first point of intersection I have found then is negative 6, negative 10. Okay, and then for the second solution for x equals 4, again, I'm going to choose to plug it into this equation rather than this one because it's a little bit less work. So when x is equal to 4, y is equal to the x value minus 4. Again, x minus 4, which is 0. So the other point of intersection is 4, 0. Okay, and then one more example for notes. Again, every time, every new example is just a little bit more complex. So we have a quadratic function e and a linear function f, and we want to find their points of intersection. So again, when does x squared plus 6x minus 65 equal 5x plus 25? Okay, so again, we want one side of the equation to be equal to 0 since this is a quadratic, and then we can factor and solve. So I'm going to move the 5x over by subtracting, and it goes right under the 6x. And the 25, the constant, is going to go right under the minus 65. Okay, so again, bring down the x squared. 6x minus 5x is just 1x, so I'm going to write plus 1x. You don't need the 1 there, but it's a good reminder. And then negative 65 minus 25 is negative 90, so minus 90 equals 5x minus 5x is 0, 25 minus 25 is 0, so this side is just 0. Now I'm going to factor. The x squared breaks apart into x and x. And then I'm looking for factors of negative 90, the constant, that add up to 1, the coefficient of the middle term. So I know I'm going to need to use 10 and 9 because 10 times 9 is 90, and I'll make the 9 the negative value So when you multiply, you get negative 90, and then 10 plus negative 9 is 1. So x plus 10 times x minus 9. So from x plus 10, we get a solution of x equals negative 10. And from x minus 9, we get a solution of x equals 9. And then finally, we have to figure out, we have the x values, what are the y values, so that we have our ordered pair for a point of intersection. So if x equals negative 10, I'll do that one first. And looking at function e versus function f, it looks like function f is a little bit less work. So y is equal to 5 times negative 10 plus 25, which is negative 50 plus 25 is negative 25. So negative 10, negative 25 is a point of intersection. And the other one comes from x equals 9. I have to hurry because class is just about out. From x equals 9, I'm going to plug it in. So 5 times 9, which is 45, and then add the 25. 45 plus 25 is 70. So 970 is the other point of intersection. All right, there are some practice problems on the back side for you, along with some review. Hope that was helpful.